All right, moving on to Unit 1, Lesson 4, More Explore, page 4. There were, we were translating different word problems into different categories, and we were saying one is abstract, one is part problems, and the other one I like to call rate problems. It's a little easier to figure out that something is a rate problem because it's involves a scenario or sets up a story that implied in the problem. um, we're looking for an unknown. Sometimes rate problems have the word per in there, like miles per gallon, gallons per minute, dollars per copy, etc. The rate is, or a specific amount of something changes by in the story, can be increasing, negative, going down, or increasing, positive, or going up. There's many words that describe that kind of action. Um, and then something, we're talking about books or years or inches or copies or miles or something. Number of something is multiplied by this rate. So also there's a starting number sometimes if we're going from this to this. So many miles are increasing as we do something, starting with this number, that kind of thing. So typically at the end, we're trying to find a final cost or an ending number. But sometimes what's missing is what is it going up by? So, what is the rate? Where did we start from? If we started from a certain place that's unknown and we ended up here, how did we get there? The rate and the rate of change and the number of something that changed and that kind of thing. So there's typically certain parts. So I just call this the end amount. This could be the total amount, the cost, that kind of thing. And then there's the rate, which is always multiplied by the number of something. So the end amount, the rate, the number of something, and then sometimes you have a start number. The start number may be omitted altogether in a problem. You might not have one. So you at least have three things, maybe four things, and any one of them could be represented by your unknown variable. Okay, so we have to figure out if it's a rate problem. Is there rate wording in the problem? Maybe something's increasing or decreasing. By how much would be the rate? Okay. And then if you have a rate, you might want to consider whether you're having a start amount or not. And then the ending amount, or maybe I don't know the rate. Maybe I don't know where the number started from. And is there a variable they're asking for us to use? So we want to set up an equation that has these four things, three or four things, using a variable they gave us in the problem. Okay. So example, Tyshawn received a paycheck for this total amount for 1 week of work. He gets paid this much per hour. Assuming no taxes out, how many hours did he work? Write an equation that has H for the unknown and solve. So the rate is $12.75 per hour. Okay, the paycheck, the total paycheck was this 471. So the 1275 is multiplied times whatever the number of hours are. Okay, so focus on what they're asking. How many hours did they work? So in this case, that's the number of something, which is going to be multiplied by the rate. We just don't know what it is yet. Okay, so to solve a problem that looks like this, so this is our setup equation. You need to have that first on your paper. So like 10 minutes ago, you might have known the answer to this problem, but the purpose of this class is learning how to write the equation with the variable. Okay, that's required. So how do we solve? Now you can set aside the context once you get it in place. And we want to get this variable by itself. We want to isolate it by dividing by the same. And if we're going to divide this by the same, we're going to divide that. And then our final answer is he worked 37 hours. Okay, and you can put that back in and double check that 37 times this does equal his total amount that was on his check. So let's do another couple of these. Maria needs to order some advertising flyers for her company. She budgeted to spend a total of 170 on flyers. That seems like a normal situation. So we got to find out how much it costs to make these flyers. So apparently the setup is quite expensive. It's $57.50 to set this up, and then the rest is for the number of copies made. So if the copy rate is 75 cents per copy, how many copies in the small letter C can she order? Write an equation and solve. So the rate is clearly the 75 cents per copy. The number of something we don't know, so that's where the C is. Okay, that's right here. And the one-time fee or start number goes here. And then the total we're allowed to spend is the 170. Okay, so how do I set all the wording aside? Now I need to solve this. Well, you need to move the term that's on the same side of the equation with the term that's have as our unknown. So we need to move this constant to the other side by adding its opposite to both sides. So that reduces this 170 to that. And then that pays for the startup costs. And all we have to do now is find out how many copies we can make at 75 cents each. So we need to isolate that C by dividing by what's in front of it. And then 112.50 divided by 0.75 is 150 copies. Okay, and you can certainly put that back in and check that that's how many copies were allowed. All right. And then the last one here, it says the annual rainfall is decreasing in some parts of the country. A county in California calculated their annual rainfall is decreasing by this per year. So a rate is 0.15 inches and it's decreasing. So make that a negative, right? Going down per year. In 2017, the rainfall was this many inches. That's our start number or one-time fee. That's the number on the end of the equation, because it's going to ask how many inches of rainfall can the county expect in the year 2030. So subtract the years, you get 13 is the number of something, because remember this is 0.15 inches per year. The per whatever is your number of something, okay? So write the equation using a R for the variable and solve. So our N number is how many inches they can expect per year in 2030. So that's going to be our R. So we don't know what that's going to be. We do know that the rate is that multiplied by the number of years it's going to be going down, plus where it was in 2017. So how much will the rain go down over the don't forget, go down, so negative. This times this is a negative 1.95 plus the positive where it was. Remember, it's not increasing per year, it's going down per year. So we have 25.65 minus 1.95. So R, or the amount per year, is 23.7 inches expected for the year of 2030, the total amount. Okay? Do the best you can on these. Just try to figure out what number goes with what, and that'll tell you where it goes in the equation.